Hello class, today we're going to be learning lesson 5-4 in your algebra textbooks. The title is being able to solve compound inequalities. So the big question is, what is a compound inequality? Well, just like compound sentences, how they're joined with the word and or the word or sometimes, the same is with a compound inequality. It is joining two different inequalities with the word and or the word or. Okay, so it's kind of combining two different inequalities. So let's look at this left-hand side. If we're starting with the inequality x is greater than -2, and I was going to draw it on a number line, and my 0, maybe 2, and -2, and it would be an open circle on -2, and it would be all the numbers that are greater than -2. So it would be going toward the positive direction in the right. And if my other inequality is x is less than or equal to +1, I was going to just draw this, and then my 0, my 1, my -1, and it would be a closed circle on +1. And it would go to the left because it's all those numbers that are either equal to 1 or less than 1. Now, the intersection of these two inequalities means if I'm going to graph the inequality x is greater than -2 and x is less than or equal to 1, it would look like this. X is greater than or equal to -2 and x is less than or equal to 1. That's like me putting them both on the same number line and seeing where they intersect, what is similar with all of them. So I have my 0, my 1, my 2, my -1, my -2. And really, by looking right here, they're going to be intersecting all the numbers that are below 1, but also all the numbers that are greater than 2. So I'm going to shade everything that's in the middle. So when I rewrite these two inequalities as one compound inequality, it reads -1 is less than all of the different solutions that are also less than or equal to +1. And this is how it would be graphed right here. Now looking on the right-hand side, I have two more inequalities. This time we're going to do the union of them. So let's start just by looking at what each of these inequalities look like on a number line. 0, 1, -1. If I was going to graph this, I would fill it in on the number 0, and it's all the numbers that are greater than or equal to 0. So it's all these that are going in the positive direction to the right. And then if I was going to graph the inequality x is less than -1, I would have an open circle on -1, and it's all of those numbers that are getting smaller than -1. So it's going to be going in the opposite direction. So when I look at the union of these, I'm going to graph all of the solutions where x is less than -1, or all the solutions where x is greater than or equal to 0. So again, for the -1, it's all of the solutions, just like I graphed above, that are less than -1, or it could be any of the solutions that are greater than or equal to 0. So this is kind of the opposite of the intersection. Intersection is everything in the middle, where the union is everything on the opposite sides. So sometimes we're going to be given a phrase, okay, where we're actually going to have to translate what it's saying into an inequality and then deciding how to graph it. Okay, this is called a verbal inequality. So let's read our first one. It reads, all real numbers that are greater than -2, I'm going to underline that, and less than 3. So if I was going to write those two statements by itself, I would say all the real numbers that are greater than -2, and I would also write all the real numbers that are less than 3. And I'm going to combine those with the word and. So to do that, I'm going to try to rewrite it going from the smallest, which is the -2, have that first. So -2 is going to be less than x. And then x is also less than 3. So I've successfully combined these two inequalities into one compound inequality. And now when I graph it, 0, 1, 2, 3, -1, -2, -3. It's going to be all the numbers that are bigger or greater than -2, not equal to it, but also all of the real numbers that are less than 3. So it's going to be everything in between. Looking at my next verbal inequality, it reads, all real numbers that are less than 0 or greater than or equal to -2. So let's start by translating that. All the real numbers, so that's x, that are less than 0, or all the real numbers that are greater than or equal to 2. Now, since it has this word or, I'm actually not going to combine it like I did for the intersection. The union, I'm going to leave it as two different ones, but I can graph both of these on one number line. So it's going to be all the numbers that are less than 0, so it's going to be an open circle on 0, and everything that is smaller than it, so I'm going to shade going to the left, but also it could be any of the solutions that could be equal to 2, so I'm going to shade it, but also greater than it, so that's going to go to the right. So this is just some good practice, some good examples for you to look at of just how to translate some verbal inequalities, how to rewrite them, and then how to graph them. So let's get into some real examples that you might be facing. The first one is going to be a compound inequality. It says 2 is less than x plus 5, which is less than 9. Now, an easy way to look at this is to picture it as two different inequalities. 2 is less than x plus 5. I'm going to write that down. But you could also look at it as x plus 5 is less than 9. And I can solve both of these. So let's start with the one on the left. To get x by itself, I'm going to subtract 5 on both sides. And I'm left with -3 is less than x. On my opposite side, if I subtract 5 on both sides, the 5's cancel out, and I'm left with x is less than 4. And if I'm going to combine these back together again, like I had at the beginning, to rewrite the intersection, -3 is less than x is less than 4. Really wasn't that hard, was it? So let's graph this. We're getting pretty good at it, I think. 0, 2, 4, -2, -4. And it's all those numbers between -3 and also +4. It's not going to be equal to them, but any of those real numbers in between it, it's going to be my intersection. So this was one way to solve a compound inequality. Another way, though, is not by splitting it up like I did here. I don't know if you noticed, but on both sides, I subtracted 5. So looking here, whatever I did to get the x by itself on the middle, I did it to both sides as well. So why don't we do that over here? This time this is -5 is less than or equal to -x minus 3, which is less than or equal to 2. So to get the x by itself, first I need to add 3. So I'm not going to split it up this time. Instead, I'm going to add 3 to the left-hand side. I'm also going to add 3 to the right-hand side. And I already did that to the middle. So all parts of this compound inequality you're going to need to do it to. -5 plus 3 is -2. Rewrite it. Is less than or equal to -x. The 3's cancel out. I'm left with less than or equal to 2 plus 3 is 5. But I still have this -x. Don't forget that's the same as -1. It's like an invisible 1 there. Well, what if you had -2 is less than or equal to -1x? You would solve it by dividing both sides by -1. I can do that the same on the left side, in the middle, and also on the right side. Now this is where it's going to get a little tricky. I am dividing an inequality by a negative number. And if you remember, when we do that, we're going to be flipping the inequalities. So now I can do that. -2 divided by -1 is +2. -1 divided by -1 is just simply x. And 5 divided by -1 is -5. Now, like I did before, I want to rewrite this just so that it goes from the smallest number to the largest. So I'm going to rewrite it, which is actually going to flip the inequalities again. And now it's much easier to graph it this way, going from the smallest number to the largest. I almost ran out of room there. So this time it actually can be equal to -5. And it's going to be all those numbers in between -5 and +2. So I've successfully solved this very complicated compound inequality, and I've graphed it as well. So we're going to do one more example. This time it's with a union of two different inequalities, and they look completely different at the beginning. We're going to solve them, and then we're going to graph them together. So let's just solve it one inequality at a time. 2x plus 3 is less than 9. Get the lonely number away from the variable, so subtract both sides by -3. I'm left with 2x, the 3's cancel out, is less than 9 minus 3 is 6. One more step, divide both sides by 2. 2's cancel out, and x is less than 3. That was pretty easy. Let's do the same process on the right side. So 3x minus 6 is less than 12. I'm going to add 6 to get the variable by itself. So get rid of the lonely number. The 6's cross out. I'm left with 3x is greater than 18. One more step. Divide both sides by 3 to get the x by itself. The 3's cancel out, and x is greater than 6. So now I have two inequalities. This is going to be the union of them, putting them both on the same number line. Almost ran out of room again. All right, this time it is all the numbers that are less than 3. So it's going to be an open circle on 3, pointing to the left. So they're all getting smaller. But it's also all of those numbers that are greater than 6. So it's going to be going in the positive direction. So I hope that you've now understood all of this. I'd like you to practice these two problems here by solving them and graphing them before you come to class tomorrow, and we'll check your answers.